Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and I am back with a new tutorial. Presently we are studying marine auxiliary systems. In this lecture we will first learn about the purpose, construction, operation and maintenance of duplex filters. Next we will explore the purpose, construction and operation of backwash filters. Then we will study the purpose, construction and operation of fine and cartridge filters. After that, we will discuss the purpose, construction and operation of magnetic filters. Finally, we will study the purpose, construction and operation of centrifugal filters. Let us now go through each of these topics one by one in the following slides. Duplex filters. This sketch shows a duplex filter which allows continuous operation and is generally used for filtering, lubricating or fuel oil for ships' diesel engines. It consists of two cylindrical containers separated by ball valves or the inlet and outlet sides. Some duplex filters are equipped with three-way cocks instead of ball valves on the inlet and outlet, allowing either chamber to be isolated or both to be used simultaneously. A perforated metal or wire basket filter is suspended in each chamber to trap foreign particles. These filters provide coarse filtration and can trap particles sized between 50 and 100 microns. Flow through these units is from the top into the basket and out from the outside of the basket. Usually, one unit is in operation at a time while the other remains on standby. Each chamber is closed at the top with a cover, and sealing is achieved using a gasket or seal ring. Each chamber of the filter body is also equipped with a drain to facilitate cleaning of filter element. The cover is equipped with a purge cork to facilitate drainage of oil while the filter is being cleaned and to remove air after cleaning and refilling oil in the chamber for immediate use. If the filter in use becomes clogged, as indicated by the pressure difference gauge, the standby filter is put into operation and clogged filter is isolated for cleaning as per the following sequence. Before cleaning the dirty filter, ensure that the clean filter is purged of air and ready for use. This can be confirmed by slightly opening the purge valve on the filter cover and adjusting the three-way cork towards the clean filter. When oil flows without any air bubbles, the filter is ready for use. Close the purge valve and fully change the cork position to this filter. Confirm that the dirty filter has been isolated by opening its purge valve. If no oil comes out, the filter is ready for cleaning. Drain the remaining oil from the filter cage. Open the cover, remove the filter element and blow service air through the wire mesh in the opposite direction of the oil flow. Check the condition of sealing gasket, reinsert the filter element into the body and tighten the cover. Close the drain, open the inlet towards the filter. When all the air is purged out, filter is ready for use. Not wire self-cleaning or backwash filter. Backwash filters are used in demanding applications where automatic cleaning is required to ensure process continuity. They are commonly employed in ships, fuel oil, lubricating oil, or hydraulic oil systems. The filter incorporates a cleaning mechanism that provides a high level of cleaning efficiency with minimal product loss during the cleaning cycle. This picture shows the arrangement of a backwash filter using notch wire filter elements driven by an electric motor. The filter casing made of cast iron is provided with inlet, outlet and drain connections. Approximately 16 notch wire filter elements are mounted between the bottom and top plates in two rows. Dirty oil enters the filter axially from the bottom while clean oil exits radially through the outlet. Notch wire filters are made from specially shaped wires, usually V-shaped or wedge-shaped, arranged in parallel with precise gaps between them. The typical filtration range is between 10 and 25 microns. A sealed ring around the bottom plate separates the dirty side from the clean side of the filter casing. A hollow central space is formed between the two plates, through which a central tube is rotated by an electric motor via a gear mechanism when the filter requires cleaning. Support arms hub acts as bearing for the rotation of central tube and hold the filter stack in place. The backwash arm sequentially communicates with each filter element to clean it by inducing a reverse flow of liquid and collects the dirty oil through the central tube. A differential pressure switch monitors the pressure difference between the inlet and outlet. When this difference exceeds the preset value, typically 0.6 bar, the backflushing operation is initiated. During the backflushing process, the drain valve remains open. Cleaning is carried out by reversing the oil flow, causing dirt and debris to detach from the inlet side of the filter element. When the backwash arm aligns with the filter inlet, the contaminants are directed to the backwash chamber via the collector arm, and the contaminated oil passes through a bypass filter to trap the dirt. The cleaned oil is then returned to the pump's suction site. Backwashing time per element is typically 1.5 seconds, and it takes about 30 seconds to complete one full cycle. Once the cycle is completed, the electric motor stops and the pneumatically operated drain valve closes automatically. The bypass filter should be cleaned before the start of each voyage. If the backflushing becomes ineffective, an alarm is usually triggered at a differential pressure of about zero point 0.8 bar. In such cases, the filter elements must be cleaned manually, and the cause of the excessive oil contamination should be investigated. A minimum pressure of 2 bar is generally required for effective backflushing. However, this can be reduced to 1.5 bar by oversizing the strainer and performing backflushing more frequently. Cartridge or fine filters. Fine filters are used to remove the smallest dirt particles from oil, typically in the range of 1 to 10 microns. They are full flow units, meaning all the oil supplied to the engine passes through them for cleaning. The filtering medium may be made of natural or synthetic fibrous wood, felt or paper. These filters generally have a short fixed service life, after which they must be replaced. However, on ships, fine filters are often reusable and may be made of stainless steel, ceramic, or sintered metal. This sketch shows a cleanable cartridge filter commonly used on ships for steering gear or emergency generators. A steel division plate separates the steel pressure vessel into filter case and filter body. The filter cartridge is screwed into the division plate and the outer casing is secured to the filter body. Oil enters the filter body from left side and passes through the ports in division plate. The oil then enters the filter element radially. Impurities are trapped on the outer surface and the clean oil leaves actually through the outlet on the right side. Some lubricating oil filters are equipped with a bypass arrangement to prevent stoppage of the critical machinery when filter becomes dirty. The filter cartridge is held pressed on division plate by a spring. Oil enters the filter body from the right side, moves actually through the element. Impurities are trapped on the inner surface and clean oil leaves radially. Finally, the oil passes to the ports in the division plate and leaves filter body from the left. When the filter becomes dirty, increased pressure on inlet side compresses the spring and filter lifts up. The bypass ports are opened and the oil gets bypassed to the outlet, which can be seen from the indicator. When the filter bypass is observed, it should be cleaned at the earliest opportunity. A purge and drain plugs are provided to facilitate draining oil before cleaning and removal of air before putting into service. Magnetic filter. Magnetic filters are used in the lubricating oil systems of diesel engines and in the gearboxes of steam turbines to provide additional protection where iron or steel wear particles are likely to be present. The sketch shows the construction of a magnetic filter which consists of a cast iron or mild steel housing. The top cover contains brass rods to hold permanent magnets. The permanent magnets are secured on the brass rods by brass washers and nuts. Iron filter cages are attached to the permanent magnets which trap ferrous wear particles suspended in the lubricating oil. Drain plug is provided on the filter housing to facilitate draining before maintenance. These filters are installed in the lubricating oil pump suction lines to protect bearing and gears from further damage. Removing the ferrous dust trapped in the filter case is time consuming and requires wiping the cage with cotton rags. These filters can remove ferrous particles as small as 1 micron but are unable to filter out non-magnetic material. Occasionally, they are combined with a basket strainer to serve a dual purpose. Centrifugal filter. This is the bypass filtration method used for purifying lubricating oil in a trunk type engine on ships, such as diesel generators, where unburned carbon from the combustion chamber enters the crankcase through blowpipe. A small portion of engine oil from lubricating oil pump is diverted to this filter. Pressurized oil enters the filter housing and flows into the drum rotor, which is free to spin on a bearing and seal. The sketch shows the construction and operation of a centrifugal filter, which is often mounted on the crankcase cover of ships' auxiliary engine to extend the surface life of lubricating oil and increase the interval between oil changes. It consists of filter housing which is mounted on one of the crankcase covers of generator engine. A rotor is secured on the filter housing which has its inner case to collect the debris. Outer cover surrounds the rotor which also supports its upper end. The rotor shaft is hollow which supplies oil for filtration. Dirty oil is supplied to the filter housing by a branch pipe of engine's lubricating oil pump. A spring-loaded check valve ensures that the filter operates only when the engine has adequate oil pressure, with the excess oil being used for filtration. The rotor has two nozzles mounted in opposite directions to each other, which operates the rotor due to the thrust created by the oil leaving the rotor. Cleaned oil is returned to the engine sump from the filter housing. This completes our study regarding the purpose, construction, and operation of various types of filters used on ships. This book has been written by me and covers all the topics as per Indian Maritime University syllabus. It explains key concepts using simple illustrations. The book also includes answers to all questions that have appeared in examinations conducted by Indian Maritime University. I am sure that the book will help students prepare effectively for exams and also support them in working safely with marine auxiliary systems. I hope you enjoyed the lecture. Feel free to share your feedback in the comment section. If you found this tutorial helpful, consider sharing it with your friends. Subscribe to the channel to stay updated with the upcoming tutorials. I'll be back soon with a new lecture. Thank you for watching till the end.